Algebra 2, this is Chapter 4, Section 2. This is the fourth video in this series. We're going to talk about multiplying a matrix by a scalar and what that means. So here is basically the definition. If you want to pause and write this down, you can, or you can just wait and see what it all pans out on in the next two slides. Basically, a scalar multiplication means that we are multiplying one number times every single element inside the matrix. So you're going to multiply k times a and get ka, k times b and get kb, k times c and get kc. So again, if you want to pause this right now and write this all down, you can. Otherwise, just hold on and see what it looks like when you really do it. So if we wanted to multiply this matrix A, and we want to find 3A, that means we're taking 3 and we're multiplying it by that matrix. So we're going to multiply 3 times every single element in here. So it's kind of like a distributive property if you want to think of it that way. So I'm going to take the 3 times the 2 and get a 6. And I'm going to take the 3 times the 1 and get a 3. And then the 3 times the negative 1 and get a negative 3. And 3 times the 3 and get a 9. 3 times 0 is 0. And 3 times 5 is 15. And that would be your answer. Your resultant matrix would also be the same dimension. So this was a, this is a 3 by 2. When you start with, so you started with a 3 by 2, and you end with a 3 by 2. That will always happen when you're multiplying by a scalar. Let's go one more example here. So I'm going to take this matrix, and this is a 3 by 3 matrix, and I want to multiply my matrix A times a negative 2. So I'm going to multiply every element in there by negative 2. And so negative 2 times 2 is going to be a negative 4. Negative 2 times 1 is a negative 2. Negative 2 times 8 is a negative 16. Negative 2 times negative 1 is positive 2. Negative 2 times 3 is a negative 6. Negative 2 times 11 is negative 22. Negative 2 times 0 is 0. Negative 2 times 5 is a negative 10. And negative 2 times 4 is a negative 8. So I started with a 3 by 3, and my resultant matrix is also a 3 by 3. And again, you're just multiplying the number that's out in front times every single element inside your matrix.